in order to do the definite integral, we need to know some of the properties of an integral. So the first property is order of the integral rule. So if we have an integral going from the lower limit a to the upper limit b of f of x dx, but this happens when a is less than b, meaning a is the lower limit and b is the upper limit. What would happen if we reverse a and b? So this is a property. So if I want to put a up here and b down here, that would just mean, so I'm just going to say it, is equal to, if I switch them around and put a on top and b in the bottom, I can just put a negative in front of the integral and they would be the same. So it's a good, you actually will use this a lot, where you have to switch the upper and the lower limit around to make things work. Okay, so the zero rule. If you have an integral from a to b, and a is less than b, because it's the lower limit and b is the upper limit, what would happen if a actually equaled b? Yeah, it would be 0. Does that make sense to you, that it would be 0? If you're going from a to a of f of x, that, dx, that would equal 0. So think about a picture of this, and you have some f of x, right? And right now you have from a to b, and that would be some area. But if a equaled b, then it would be essentially no area, right, under the curve. Make sense? Okay, so here is some constant rules, kind of like constant rules when we did limits. If we have an integral from a to b of c of dx, actually we already know this rule, right? If it's a constant, we just take the constant and times it by b minus a. However, if we have a constant times a function, we can actually take the constant out of the integral, integrate the function, and just multiply it by c at the end. Does everybody see what I'm saying here? So I can actually take this c and put it in front of the integral. That is, and we've done that for limits, right? Where we take the constant or the coefficient out of the limit and we put it in front. So if c is -1, does everybody see the negative I can stick in front as well? And then if I wanted to make the integral positive, what could I do? Instead of negative and integral, I can make this positive by switching those around if I need to, right? Okay, sum and difference. Basically, I can integrate separately just like I did limits, so they can be rewritten like that. Okay. The next one, the additivity rule, we use quite a bit. So if we have an integral from a to b, so I'm going to give you a picture of what this looks like. So we have some f of x here, and we have a and b, and we have some c in between. Does everybody see? I could actually, instead of, so say I can't actually find the total area from a to b, this big rectangle, I can actually break it down. C doesn't have to be the halfway mark. C just has to be between a and b somewhere. And I can break it down to from a to c, and then from c to b. And that would be the same result of the integral going from a to b. Make sense? Actually, maybe, I was going to do some examples, but I'm kind of just, we'll do some examples now, I guess. Evaluate the integral from 1 to 3 of negative x squared plus 4x minus 3 dx using the following values. So they say that from 1 to 3 of x squared is 26 over 3, from 1 to 3 of x dx is 4, and 1 to 3 of dx is 2. So does everybody see what properties we're going to use? We're going to break them all apart, right? So from 1 to 3 of x squared dx, the negative can go in front. Does everybody see what I just did? And then I can put plus 4, the integral from 1 to 3 of x dx. That's the same thing, using those properties that I just showed you. And then minus 3, the integral from 1 to 3 of dx. This one I could have had the 3 inside, but the reason I put it outside is because it gave you some information what dx actually is. So now what I'm doing is I'm going to replace the integral of x squared dx with 26 over 3. However, there's a negative that has to be there. Then I'm going to replace the x dx with 4. So, and this happens to have a 4 in front as well, so it's going to be 4 times 4. And then it's going to be minus 3 times, what's this value? Well, it is 2. So minus 26 over 3 plus, this is 16 minus 6. 16 minus 6 is 10. So what is minus 26 over 3? And then if we had 10, that would be what over 3? 30 over 3. So then we get 4 over 3. Okay, so do you want to try the next one? The next one uses how we take apart from 0 to 10. Do you know from 0 to 10? There's a 2 and a 5 and all that between. Do you see we can actually make an integral of 0 to 10 with these values? So what would we try to do here? From 0 to 10 of f of x dx. Well, first off, we have to start at 0. The only one that has 0 is 0 to 5. Does everybody see that? So now we are from 0 to 5. Well, obviously that's not the same as 0 to 10, so we need to start building. It would be perfect if we had a 5 to 10 integral. We don't. So we have a 2 to 5. However, we can't build a 0 to 5 unless the 5 is at the bottom. So what do I need to do here?
Do a 5 to 2.
We need to do a 5 to 2, and I can only do that if I switch the sign. Okay, so now, does everybody see what I have now? From 0 to 5 and 5 to 2, I really have a 0 to 2 integral. Make sense to you? Going from 0 to 5 and then 5 to 2. I'm essentially going from 0 to 5, and then I'm subtracting the 5 to 2, so that what I have left is the 0 to 2 right now. So does everybody see visually? 0 to 5, I'm subtracting the 2 to 5 out of there, so really all I have right now is a 0 to 2. Yeah, in your head, that's essentially what you're doing. The 5s are kind of canceling, and you're just left with the 0 to 2. Very good. That's how I kind of picture it, too. Did you have a question?
Wouldn't setting it to negative and from the 5 to 2 make you adding is giving more area? Because flipping the 5 and 2 from the original would already make it negative.
But that's when I flipped it, it became negative. Right now, you see the way it's written, it would have been positive. So in order to actually write it from 5 to 2, it would have to be switched signs. I don't know if that's what you're asking.
I'm just thinking that the 5 to 2 effects dx evaluates to a negative number, and then the negatives are the outside. So then we have a double negative.
You'll see when I put it in. Okay, so now I have 0 to 2. Does everybody see that? I know what you're saying. You'll see it's the same thing. So from 0 to 2, so now I can use this 2 to 10. So plus 2 to 10 f of x dx. Does everybody see when this all kind of cancels and puts together, I have a 0 to 10 integral now? Okay, so 0 to 5 is this one right here. So this represents a 3. Yes? Then we have a subtract. And we have a 5 to 2, but the problem is I have a 2 to 5, and that represents 4. Does everybody see that? So, what do I really want then?
So you want, is it a negative 4 and then a minus?
Yes, it would be a negative 4 then.
So it's still plus. Is that
So
what
then, yeah, that's what Josh was trying to say before, for sure. Yeah. Yeah, so you guys, hold on a second here. I screwed up. So this should be a plus because we're building this integral. Do you see this? If this is 0 to 5 and 5 to 2, I have to add them all together to get 0 to 10. It's over here that I'm switching it to get the negative. Does that make sense to you? So this is not 5 to 2 up here, it's 2 to 5. So do you see I can't use positive 4, I have to use negative 4 in there. Very good catch.
I understand it the first way you explained it, but it was wrong, and I understood it.
No, but I guess what I'm trying to say, and I will clarify, and I apologize that it was screwed up the first time. In order to build an integral from 0 to 10, we have to add a whole bunch together.
Well, because
But do you see, if I go from 0 to 5, and then go from 5 to 2, I'm essentially subtracting. Like if you look at the picture 0 to 5, and then the 2 to 5, I'm essentially, when I add that together, I'm taking that out. Because of the fact that this is the wrong way, right? Which is the subtraction.
Change it from 2 to 5. Don't you have to put a subtraction sign in? Isn't that like a rule we just learned?
No.
Okay, so I guess what I'm trying to say is I'm building it right now. I'm not even looking necessarily at this. I'm building 0 to 5, 5 to 2, 2 to 10. And then now when I substitute this in, this wasn't 5 to 2, this was 2 to 5. So I have to switch this to a plus or minus 4.
It's no longer negative.
Right. Right.
So, but I guess what I think what he's trying to ask is when would you add in that negative sign until like your equation, etc.
Okay, let's try this again. So example 3, we have an integral of negative 3 to 3, and that equals that, of f of x. This is g of x. And now we have this concoction. So we need to figure out the value. So I would build this using our rules. So the integral from negative 3 to 3, how could I separate 3f of x? 3 in front of f of x dx. So now, how could I separate the minus g of x over 2? Yeah, take it as a minus 1/2 and put it in front of g of x dx. And then how can I deal with this minus 1/6? I can put it in front if you want, again. Negative 3 to 3 of dx. But we know what this is equal to, right?
Yeah, it's not given, but it's 1.
Yeah, it's going to be 1. Yeah, it's not given, but this is a rule we learned the last lesson. This would be the constant times this, subtract this, right? Okay, so this is equal to 3 times 2/3. Does everybody see that? Are we good with that? And then this is 1/2 times what's g of x equal to? Minus 8? Yes? And then this is equal to minus 1/6 times 3 subtract negative 3. This is a rule we learned, right? Where we have that constant, and it's just that rectangle of that minus that, yeah? Okay, so the 3 and the 2/3 will cross cancel. Yes? And we're left with 2. The 2 and the 8 will cross cancel, and I'm left with a 4. And it's minus 1/2 times minus 8, so that's going to be a plus 4. And then 3 minus minus 3 will give me 6. And then 1/6 times 6 will cross cancel, and I'm left with minus 1. So this is 6 minus 1, which gives me 5. I'm going to give you a second to see if you can figure out if this is true or false.
Wait, what about 4?
Oh, sorry, number 4. Oh, there you go. Can you come up with the number that would have to be?
Could be. It could technically be anything. As long as it starts with...
So do you see if it ends at 7, this would have to be 7 here? Yes? Okay. If this is 5, in order to build this, this would have to match
And then that would be a
And then because this is a 4, this has to be a 4, yes. 7. This is a 7 right here. Okay, I'll give you a second to do the true or false now. Sorry. The true or false. Okay, so A is 0 to 1 of sine x plus cos x. So they're saying you can split them up.
yeah.
Is that legit? Yeah. That's just the additive property, right? You can split up a function. Addition of two functions can be split up in two integrals. Okay, the next one says basically they're taking the integral and splitting it up as a multiplication of 2. Can you do that? No, you can do it with addition or subtraction, but I never went over multiplication or division, so you can't do that. So false.
The rest of that would be the x goes in front, right?
No, you can't pull a variable in front. You can't. The only thing I would do is probably multiply this in before I try to integrate it, right?
You can multiply it in and then separate it.
Yeah, so
it'd be x.
so then 0 to 1 of x cubed plus x dx. Then I could separate it as 0 to 1 of x cubed dx plus 0 to 1 of x dx. That's the only thing I could do. Does everybody see what I did? There's no multiply rule, right? Okay, next one. Actually, this is what we were just talking about. Can you pull out the x in front of an integral? No, you can't do that. Only a constant. So this is false. Only a constant can be pulled out. And I know that x is not a constant because it's integrating with respect to x. So I know it's part of the function. Okay, the next one is 0 to 1 of x times t squared plus 1 dt. So this time I pulled out an x. Yes, in this case they tried to trick you. X actually is a constant because you're doing it with respect to t. So this is actually true. X is a constant in this case. I know those tricksters. Okay. The next one is 1 to 3 of 1 over x squared dx is 1 to 5, and then 5 to 3. So is that true?
Yeah.
True. This is just what we were discussing. So again, it's like I call it the Carson cancel now. The fives cancel and we add them together, the Carson cancel. So. Oh, I like that better. Sorry, Carson. The dominoes, right? Where you have 1, 5, and then the 5 to whatever. No. Ah, you guys don't know how to play dominoes. Okay, so
I don't want to do dominoes to step up
and knock them down, yeah. Okay, the comparison properties. If the function is positive, meaning it's above the x-axis for a, that's between, so for x between a and b, then the integral from a to b of f of x has to be positive. Well, let's think about that for a second. Does it make sense to you? If the function is positive, that means it's above the x-axis, right? And if I'm finding the area above the x-axis is positive, so that makes sense that the integral would then be positive, yes? Okay, so let's look at the second kind of comparison property. If f of x is greater than g of x, and x is between a and b, then the integral, it has to be, meaning the area of that function has to be bigger. So I'll give you again another picture. Again, if we have f of x here and g of x here, and here we have a and b, does everybody see that, like just visually, that the area of f of x, which is this whole thing, and the area of g of x is this whole thing, f of x is a bigger area than g of x, right? Okay. So the next comparison is if little m is the minimum and big M is the maximum for x between a and b, then you can take the minimum, which is, remember, that's a constant then if you know what the minimum is, and b minus a, so that's that one integral formula, right? And the integral between the minimum and the maximum has to be between those two areas. So I'll draw a picture for that. Can I put it here? Okay, so I don't know. We can have something like this, and then there is B, and there is A. Okay? And so this, of course, is my M. This, of course, is my little m. Does that make sense? Okay, so they're saying if I have to use a different color pen here. If I were to make the area from A to B for big M, do you see it's a pretty big area? That rectangle? Yes? And I use a different color pen here. If I make the area here of that height, do you see that's a pretty small area? So what they're trying to say is the integral, meaning all the area from A to B of this curve, has to be an area between the max area and the min area. Did you see the visual now? So, and then you have, I don't know if this is going to get messy now if I color everything. Versus the blue area would be, that part, right? So they're trying to say the blue area has to be between the green area and the red area, essentially.
Oh.
Okay. So it says here, estimate the integral from 1 to 4 of the square root of x dx using the absolute max and min property. Okay. So let's draw a visual. This actually, the property we just did, it'll make sense once we draw this. Does anybody remember how the graph of the square root of x looks like? Yeah. So 0, 0, like this. And so at 1, does everybody see at 1, what's the height there? 1. And at 4, what's the height there? 2. Okay, so what's my min? Remember, we're doing from 1 to 4, not 0 to 4 here, right? Like I'm trying to figure out what this area is right here. So does everybody see my min is my that, and my max is that? Yes? So my min is 1, and then it's going to be 4 minus 1. So that means my area is 3 for my minimum area. And my maximum area is going to be my maximum, which is 2, times 4 minus 1. So that's 2 times 3, which is 6. So using the min-max properties, it says that the integral from 1 to 4 of the square root of x dx has to be between 3 and 6. Does that make sense to you? Can anybody think they could estimate, since we know we can narrow it down, it has to be between 3 and 6, roughly, what do you think that area is?
4.6.
Like if this whole thing right here, like if I were to extend this to here, do you see this is 6, and then this part right here is 3. So what? Did you say 2 point? No, it has to be between 3 and 6.
4.6 repeating.
4.8. So we're going to say an estimate is a roughly 4.8. This is just visually Carson looked at and he's like, well, it has to be a little bit below 6 because I'm just missing this little section here, right? So he said 4.8. So the actual, just so you know, the actual is 4.6 repeating. It's a pretty good estimate. Yes. And again, today, excitingly enough, if we can get to the second lesson, we are going to do that. So average value of a function. So when I find the average of a class mark, I add up all the tests and divide by how many there are. Yes? So we learned early on the first application of integrals is we'll look at the average value of a function. It's easy to calculate with a finite amount of numbers. We just add them up and divide by how many there are. So if I want to find the average value of f on an interval from 1 to f, sorry, from a to b.
So where's this one?
I don't know. I'm tired. Anyways, so if I want to find the average, it is 1 divided by b minus a times the integral from a to b of f of x. So this is something you should memorize, put it on a recipe card, whatever. This is a very important thing they ask all the time. I don't know why they think average is so important, but it is. It seems like they ask it on the exam all the time.
Average is something you can apply to more.
Yeah, but if you forget, yeah. So, but if you forget how to figure it out, then it's kind of like, well, I don't know how to do this. So just remember you have to go 1 divided by the upper minus the lower times the integral. So
if you're doing it for our test scores, how do you calculate it with that formula?
okay, so here's a question. It says, determine the average value of f of x equals 4 minus x squared on 0 to 3. Does f actually take on this value at some point in the given interval? You may use your calculator function for the integral. So does everybody see we're trying to find f average? So that is equal to 1 over b minus a. So what would that be? 3, but I'm going to write my thing out. So 3 minus 0 of the integral from 0 to 3 of 4 minus x squared dx. So does everybody remember how to punch this in? So I'm just going to simplify this. So this is 1/3 times the integral from 0 to 3 of 4 minus x squared dx. So punch it on your calculator and tell me what you get. Now you can do it separately if you want. Did you get 1? Oh, okay.
Wait, we have to type this whole thing.
Yeah.
There's no way to do it.
Well, there will be once I show you how to do it, but we're just using our calculator right now. So remember how to do this? So 1 divided by 3, and then we go math. I have to do it the crazy way, right? I have to 4 subtract x squared, comma, x, comma, 0, comma, 3.
Right, because it's function, variable, load on the
Yeah.
but I don't know.
Or you can have the fancy calculator that does it for you. But anyways, either way, you're going to get one. Okay, so then the question asks you, does f actually take on this value some point in the given interval? So I guess what they're asking you for is, do you actually get an area? Because that 1 represents the area, right?
You actually get 1 as an area.
Yeah, do you get an area of 1 somewhere in that integral?
Yes, yes.
Yeah. Does that make sense to you that you would?
Yeah, because as long
Like if you think about, okay, so maybe you need to think graphically what this looks like. What does this graph look like? Yeah, so it's at 4 and then it's kind of going down like that. Because we're only going from 0 to 3. Actually, because this is hitting at 2, it'll be negative. So 3 is actually over here. So do you see at some point, because you're going from positive area to negative area, will you get 1? Well, maybe right here you get an area of 1 here, right?
somewhere where it's positive, you can
somewhere.
squish it as much as you want
Yeah.
until you get 1.
Okay.
Why is that the average?
they're saying if you add up all the individual, essentially areas, right? The average is 1. It takes on the average of 1 through the whole thing. So, by the way, does anybody know what does anybody know what this value equals? It equals 3. So the total area between this hump and essentially this hump here is 3. And so they're saying from going from 0 to 3, the average area is 1. You know, because if you think about this as like you're accumulating the area, right? And then at some point you're subtracting the area here because this is under the curve. Okay, this is a huge theorem, the mean value theorem for integrals. It's saying there is a theorem that's related to the average function, the mean value theorem for integrals. MVT for integrals states that somewhere between the inscribed and the circumscribed rectangles, there is a rectangle whose area is precisely equal to the area of the region under the curve. So, in other words, the mean value theorem for integrals, if f is continuous on closed interval a, b, then there exists a number c. Does this ring a bell at all?
Sure.
The mean value theorem for derivatives, they said there's a c that exists between a and b such that f prime of c equals f of b minus f of a over b minus a. So you remember the derivative, because I was just setting up the slope. So they're saying here, this is basically the integral is equal to some value, because remember we have the average. It's kind of like you were asking me, how is this 1? I'm just saying somewhere in here that you have a total area of 1. So they're taking this and they're saying, oh, well, right here is this C, where if I were to find that area, that's basically the average area of all of it. But it wouldn't be right there because this would be too much area compared to that. But maybe. Okay. So, the MVT for integrals is a consequence of the MVT for derivatives and the fundamental theorem of calculus, which we haven't learned yet, but we are going to be pretty soon. Find the value c guaranteed by the MVT for integrals of f of x equals 1 plus x squared on negative 1 to 2. So if I were to plug this into this MVT formula, what would I have? The integral, what's my lower limit? Negative 1. What's my upper limit? 2. And what's my function? 1 plus x squared dx. That is equal to some f of c, right? Times b minus a. And what's b minus a? 2 minus 1. This is something we know. Does anybody think they know what it is? Look at this. What is f of c equal to?
The average?
1 plus c squared. Very good. So this is negative 1 to 2. I'm just going to clean this up again. Plus x squared dx is equal to 1 plus c squared times 3, which then if I multiply that, I get 3c squared plus 3. So we're going to use our calculator to find that value. So take your calculator and find that value. So what do you get for this? 6. So 6 equals 3c squared plus 3. So 3 equals 3c squared. So 1 equals c squared. So yes, you're square rooting it, so you should get plus or minus.
Plus plus minus 1?
And it could be, so look at your upper and lower bounds. Could you include both -1 and +1? And yeah, you can. So there is the C. All right.